In this section of Chapter 13, we're going to be looking at our epoxides again. This time we're going to be looking at how we can form epoxides through the use of peroxyacids. Remember, our epoxides are our three-membered rings that has oxygen as one of those members of the ring. Peroxyacids. Peroxyacids have the unit of RCO3H. So if we look at our peroxyacids, we still have the carboxylic acid, but now we're going to have an extra oxygen in there as well. So this is our RCOOH unit. They're going to be a little bit more reactive than what the carboxylic acids would be. One of the common peroxyacids that we will be using is MCPBA. It stands for metachloroperoxybenzoic acid. It is one of the common ones that is used, so you do want to recognize it in terms of its abbreviation. So all we're going to be doing is adding that extra oxygen in as well to what metachlorobenzoic acid would be. So this would be our structure for the metachloroperoxybenzoic acid, or MCPBA. And again, it's another one of those abbreviations that you want to learn to recognize in terms of how it will react. And these peroxyacids are going to react with alkenes to produce the epoxide. What we will see through this reaction, it is a concerted reaction. Concerted reactions or concerted mechanisms are mechanisms that basically take place in one step. So all the stereochemistry is preserved from the alkene to the ring. There can be a mixture of stereoisomers in terms of R and S if a stereoisomer is produced. Because the alkene is planar, we can see it attack from the top face or the bottom face. But the key is that if it was trans to begin with, it will stay trans in the epoxide ring. So let's look at an example of our concerted mechanism with our alkene. And I'm just going to start off with a trans alkene. And then I'm going to start off with my peroxy acid. So what we're going to see here is that the alkene is nucleophilic. It's going to be attacking that extra oxygen that we have associated with the peroxy acid. That oxygen does have lone pairs associated with it. It does have the extra bond. So we're going to see the bond break between the oxygen and the hydrogen, and we're going to use those electrons to form our three-membered ring. The bond is going to break between the two oxygen atoms. It will go to form a double bond between the oxygen and the bond of the carbonyl. The other pi bond is going to go to form a new bond between what was the oxygen of the carbonyl and the hydrogen. So what you'll want to see with these concerted mechanisms is they are oftentimes very cyclic in nature. So you can see almost this cyclic transfer of electrons. We have one cyclic transfer of electrons that's going to produce the epoxide for us. We then also see another cyclic transfer of electrons that is going to get us to our other byproduct, which is a carboxylic acid. So through this reaction, we end up generating the epoxide. And it is still going to have that nice trans stereochemistry around the ring. The other thing that we end up producing is also going to be a carboxylic acid from the peroxy acid will then generate a carboxylic acid for us. So this is our concerted mechanism that we would be looking at to go from an alkene reacting with a peroxy acid to generate the epoxide as well as a carboxylic acid byproduct.